All right. In this video, I'm going to show you, you should know if you have a triangle and you know the lengths of the sides, how to write that in component notation. That's what I showed you in the previous video. In this video, I'm going to show you how to find the lengths of the sides. So if somebody just gives you the angle and the hypotenuse or the magnitude, you'll be able to do the whole thing. Okay. Now, before we begin, we need to make sure that you are in radians. So type sine of 90. Okay. I mean, when I hit sine, I get sine left parenthesis. So type 90, right parenthesis. And if you get 1, if that equals 1 when you hit that thing, then you are in degrees. If you get some other number, then you are in radians. So find the mode button on your calculator. It might be second mode. On this calculator, it's just mode. When you do that, it brings up, if you have a TI-84, 83, or one of those things, right? It brings up all the different modes. The first one is normal, scientific. Press the down arrow. Now it's float. You could have it round off to so many decimals, right? And then there's radians and degrees. So go down and then over until it's over degrees. Hit enter and then hit clear. And do the sine of 90 again. All right? Now it should say 1. If it doesn't, I don't know, go Google how to turn your, whatever your calculator is, into degree mode, okay? We need degrees. All right? Now, these are the steps, okay? Step 1 is that we got to draw the components of these vectors, okay? We go tail to tip. So the black thing is the vector here. This is the tail of the vector. There's the tip of the vector. Tips have arrows on them, just like arrows, okay? Notice that this vector goes to the left and it goes up like that, okay? Use arrows when you draw this thing, and I'll show this over and over again in many, many examples, okay? Step 2 is that we're going to use the cosine and sine button to find the adjacent side and the opposite side. Now, look at your triangle. The component you drew first, actually, because you draw these around the angle you're given, the one you drew first is the adjacent side because it touches the angle. The one that doesn't touch the angle, that is, for example, opposite the angle, okay, is the opposite side. I don't know how to explain that any better, right? The one that is the longest side, that is the magnitude, right? Okay, that is also the hypotenuse of this triangle right there. Okay, now if I want to find these sides, okay, what I've got to do is I've got to use this little formula here, right? So let's do that for this guy here. Okay. Well, I'll do that in a sec here. And then the next step is to decide x and y. We've done that already in the previous video. Decide plus and minus, and then we've got to write the vector down. So let me do it on these guys here. Okay. Draw the components. Well, they're already drawn, but I'm going to draw it over there, right? So let's go to the left. Let's go up. Okay. So when you do this, use arrows. Go from the tail. Go to the tip, right? Find the lengths of the sides. Well, the adjacent side is hyp cos theta. So literally, I'm going to type, since 12 is my hypotenuse, 12 cos 27. I type that in my calculator. 12 cos 27. And I get 10.692. That's the length of this side. That's what sine and cosine do. They do more than that, but you know, that's one of the things they can do. And then this side here, the opposite side is hyp sine 27, right? That's this guy here, right? Okay, so that's going to be 12 sine 27. So literally I'm typing that 12 sine 27. Now if you're all hyper OCD, you can say 12 times sine of 27. Most calculators will infer that you want to multiply. 5.448 is the length of that side, right? Since these are meters, these are both meters, right? So I've done this, right? I drew those. I found the lengths of the sides using that. I have to decide x and y, plus and minus, okay? So this blue line here, this arrow that goes to the left, that is definitely in the x direction. Since it goes to the left, it's negative. This red arrow here, okay, that red arrow right there is definitely the y component, especially since that one's the x, right? Since it goes up, it's positive. So now I just have to write this. Negative 10.692, right? Plus 5.448 meters in the y direction. I've got it, yeah? All right, let's do that same thing again with this guy here, okay? I'm going to draw the vector. Let's go tail to tip, right? So I start here, and I go down like this. Okay, then I go to the right from there. Right, so notice that these things, they go down, I go to the right. They were already drawn for me, so I kind of knew what I was doing there. Okay, I drew those things. This is the hardest part. So go from the tail of the vector to the tip of the vector. You want to draw it around the angle that you're given. Right, so here I had went down because the angle was given like that, and then over. Okay, the next thing is find the lengths, find the sides. Right, so this side here is the opposite side. This side here is the adjacent side. I know that because this side touches the angle, this side is opposite the angle, yeah? Okay, the opposite side is going to be hyp sine theta. So the hypotenuse is 8. So I go 8 sine 30. Let's try that. 8 sine 30. Somewhat surprisingly is exactly 4, right? Because the sine of 30 is, that's one of those ones that comes out even, right? And then the adjacent side here, adjacent is hyp cos, right? So it's going to be 8 cos 30. That doesn't come out even. 8 cos 30. That's 6.928. Okay, now I've got the lengths of the sides. It's always good at this point to do a little double check. Since that angle's smaller than 45 degrees, I would expect this side to be smaller than this side. It is, right? So one common mistake is you just mess up the opposite and adjacent side, right? Now we still haven't decided positive and negative. Let's see. This guy is, it's definitely the x component, yes, because it's to the right, okay? And since it's to the right, it's positive, right? This guy here, since it goes up and down, is our y component. And since it's down, it's negative. So I would write this 4.0 meters x direction plus negative 6.2928, meters in the y direction. All right. So I'm going to let me do one more example here, and then I'm going to just do example after example after example. Okay. So in this video, let's do another example, right? So draw the components, figure it out with sine and cosine, write it down, okay? I forgot to decide x plus and minus and all that stuff, right? But we'll do it. We'll do all the steps. So the first step is to draw them. So start at the tail of the vector. Here's the tip, right? Start at the tail and draw these guys. Okay, now it's like an Etch-a-Sketch. You want to go up until you think you're as high as the tip, right? And then go to the left and meet the tip. And I kind of messed up there, but that's okay. You know what I'm trying to do. This side is the opposite side. This side's the adjacent side. Okay? So the opposite side is hyp sine theta, right? So that's going to be our hypotenuse is 23 meters per second. Sine of 31. Okay, let's try that. So I'm literally going 23 sine 31. I get 11.846. Okay, and that's actually meters per second. And then the adjacent side is hyp cos theta, right? So that is 23 cos 31. Okay, so 23 cos 31. And that is 19.715 roughly. And since it's meters per second is the hypotenuse, these guys are meters per second. Okay, now I have to decide plus and minus x and y. The opposite side here, since it goes left and right, this is definitely our x component. Okay, since that guy, our opposite side, the side we found was sine, right? Since it goes to the left, it's negative. This side here that goes up and down is definitely our y component. And since it goes up, it's positive. Okay? Now I've got to write it down the proper way, right? So let's see, x first, so negative 11.8 roughly, right, meters per second in the x direction, plus 19.7 roughly, right, meters per second in the y direction. There we go. All right. What's going to follow is I'm just going to do a whole bunch of examples here. So just keep doing the examples. The thing you need to practice, what people are going to mess up is they're going to mess up opposite and adjacent. They're going to mess up x and y, plus and minus. Okay. Everybody will get these two numbers, That's not what we need to show, right? What we need to show that we can do is put it properly in the x direction or the y direction, properly negative or positive, okay? One way to think about it is this. If you think of this whole quadrant, right? Vectors that end up here or here are positive x, positive y. Vectors that are here or any of these guys, right? All of these are negative x, positive y. Vectors down here, these guys, all of these guys, right? These guys are negative x, negative y. And vectors over here are positive x, negative y. That's another way to think about it. There are also videos where I show you how to use trig angles to do the plus and minus. I think that's confusing sometimes, but it's fast if you can do it. Anyway, in the next videos, I'm just going to do many, many examples for you.